First of all, good afternoon, everyone. My name is Ben Yosefa. I'm the VP for Global Market Development and Stakeholder Relations at Methanex, and also the Chairman of the Methanol Institute. It's my pleasure to moderate this panel discussion on methanol use as a marine fuel. We started with a short video. I'm not going to go over the same things that are in the video, but I just wanted to highlight a few of the key things that have come out of that. And you'll hear more about this in the panelist presentation today. But the International Maritime Organization has been drafting increasingly stringent emission regulations for marine vessels. And this has really presented a historic opportunity for the uptake of methanol as a marine fuel. And that's really given its proven reductions in air quality emissions, basically in pollutants. The other thing is methanol is a liquid fuel, so current bunkering infrastructure needs only minor modifications to handle methanol, and the cost to convert existing vessels to run on methanol should be significantly less than alternative fuel conversions in the future. Now, we're right at the beginning of this journey, and obviously the first couple of vessels are sort of like a prototype, and then as time goes on, the cost of these vessels will come down, and already it's competitive today. The other thing as well, we heard this from some of the speakers this morning, is that methanol is readily available both here in the United States and globally. And besides that, it's a safe fuel, so it's been safely handled and used in a variety of applications for over 100 years and is now proven as an attractive fuel for the marine industry. Today's panelists are here to explain more about methanol as a marine fuel and share some of the practical examples of methanol marine fuel projects and some of the commercial activities from around the world. So whether that's the Stena Germanica or waterfront shipping or the vessels there, or alternatively some of the pilot projects that we've got going, you'll see that there's a wide array of different projects and commercialization activities that are underway today. So I won't spend any more time. I'd just like to introduce each of our panelists today. First panelist is Joanne Ellis of SSPA in Sweden. Joanne, if you could please take your seats as I call your name. So Joanne is the project manager for SSPA, which offers a wide range of maritime services. SSPA has been involved in the research and demonstration of methanol as a marine fuel from the very beginning. In fact, I remember working with you over 5 years ago now, Joanne, as we developed the Spirit project, along with Per, of course, as well. SSP was the project coordinator for the Spirit project, which first showed that methanol could be a viable alternative for reducing emissions from ships. And it wasn't just methanol that was tested, but other fuels as well, and methanol was the one that was selected at the end. Our next panelist is Per Stephenson of Stena Lines, and Per is the naval architect for Stena Lines, one of the largest ferry operators in the world, and was responsible for the conversion of the Stena Germanica to methanol. Per has been with Stena since 2009 and has got expertise in the fields of standards and regulations development, project management, lightweight design, naval craft, and much more. He previously worked as a head of research and technical development for the Swedish Maritime Administration and as a marine engineer in the Swedish Navy. René Lawson of MAN Diesel and Turbo. René serves as the promotion manager for MAN Diesel and Turbo's two-stroke business. MAN is the world's leading provider of large-bore diesel engines for the marine sector. He holds an MSc in mechanical engineering from the Technical University of Denmark. And in his role as promotion manager, René looks after the market for gas-fueled merchant ships, including the market for engines using new fuels such as methanol, ethane, and LPG. René. And finally, Jason Chesko of Methanex. So Jason is the senior manager for global market development, and Jason is focused on executing Methanex's global energy strategy and initiatives to support methanol demand growth into marine fuels, being one, but also many other energy applications. Jason chairs the Methanol Institute's Global Fuel Blending Committee and sits on various other industry committees. So today, Jason will be representing Methanex's wholly owned subsidiary, Waterfront Shipping. So now I'd like to hand it over to Joanne to get us started with the first presentation.
Thank you very much for the introduction, Ben, and thank you also for the opportunity to be here to present on methanol as a marine fuel. As Ben mentioned, I work for a company called SSPA Sweden. It's the former state ship testing agency, which is now a marine consultancy and research company that has been around since about 1940, and I've been working in the research department on alternative fuels. My presentation today, I'm going to focus more on recent projects, pilot projects that are underway for smaller vessels, because most of the other speakers are looking at the larger vessel conversions. As Ben mentioned, about 5 or 6 years ago, we started with a project in Gothenburg, Sweden, called the Spirit Project, which was the first to look at methanol on board a vessel, and there we looked at both methanol and DME. The drivers for alternative fuels for shipping for all sizes of ships is the international maritime regulations on sulfur emissions have been getting stricter, and in the start of 2015 it came in a regulation for 0.1% sulfur in emission control areas, of which Sweden is in the northern emission control area. And so there was a lot of interest there in ship owners looking for alternative fuels and even after treatment technologies to see what was the most economical and best way of meeting these emission control guidelines, and methanol came up then. At the end of last year, the global sulfur requirement has now been dropped to 0.5% for 2020. It's 3.5% right now for all ships, even those not in emission control areas. So I expect that this will also drive more interest in the lead up into the 2020 deadline. As well, there are NOx emission regulations for new vessels and particulate matter and black carbon because of the health impacts, and a lot of ships operating in port areas are having concerns there. Although there are no regulations in place, there's still a lot of discussion about that. And the next driver is CO2 reduction of greenhouse gases from shipping. There have been some studies at the IMO about greenhouse gas reductions, and nothing in place yet in terms of regulations, but the European Union, for example, in shipping is looking to reduce levels by 20% to 40% by 2050, and they've had some projects looking at ways of coming down to that level, realizing that energy efficiency in shipping can achieve only so much, and to really get down to the lower levels of greenhouse gas emissions from shipping, there needs to be some movement to alternative fuels and low carbon fuels to be able to meet those deadlines. For smaller vessels, what the pilot projects that I'll be talking about in this presentation, there are other targets, some national targets. For example, in Sweden, there's a long-term goal to have zero net emissions of greenhouse gases for 2050. And so the Swedish Transport Agency, which also has a fleet of road traffic ferries, has even faster and stricter deadlines for what they want to achieve with their state-owned vessels. And you can also see municipalities around Europe and ferries are already on the move to reduce their CO2 and greenhouse gas emissions. Even some commercial ship operators are looking ahead and looking for fuels that can bring down the greenhouse gas emissions. So in Sweden, a 15% reduction by 2020 for the CO2 emissions, and a 30% reduction by 2025 as compared to their 2015 level for their road ferry fleet. And so they've been interested in looking at different alternatives and are supporting a few pilot projects for the smaller vessels. For the road ferry as seen in this picture, looking at design, and we're working on a project for design and recommendations for adapting the onboard systems to meet the marine safety standards, and how to adapt the fuel system to be appropriate to methanol. And as well, there's another project that was mentioned earlier with FitTech from China, where they've been supporting some of the engine work in the Green Pilot project for the pilot boat conversion. As well, in these projects, there is some engine research in the Summit project, the Sustainable Marine Methanol project, some engine research, as there are currently no engines commercially available in the smaller segment. This is quite a new area. The Summit Sustainable Marine Methanol Project, you can see the different partners along the bottom. We're a research project, so funded by the Swedish Maritime Administration and Methanol Institute, Western Gothenburg region, and oil tanking, and different partners including consulting companies and universities. The project, the overall aim, of course, is to contribute to a solution to reduce the emissions and carbon footprint for smaller vessels by, first we're looking at a market study of the smaller vessels in Northern Europe in the emission control area, see how many of these small vessels are out there and what the potential would be for engines and fuel. And as well, development work on the smaller engines that I mentioned, and the case study design for the road ferry conversion. As well, looking at renewable methanol supply in that region, what could be possible, because this is really important for the road ferry operator. So this shows the area covered within the project with the market study, and looking at these two smaller engine size ranges, one the 250 to 800 kilowatt, which has an automotive equivalent to a large engine in a truck or bus, for example, and then the slightly larger marine engine sizes. So the project is looking at identifying all the vessels in that size range in that area, and so far there's about 10,000 vessels identified, and then going further, looking at their operating profiles and hours, and to come up with total fuel use and the emissions reduction potential there. Some of the engine testing work, the partner, the Finnish Research Institute doing some work on an engine that has been used a lot over the world for ethanol with an ignition improver, an ED95 concept, and looking at an MD, so a methanol diesel 95 with the similar ignition improvers. And starting out with doing combustion chamber testing, and they completed their engine testing just about a month ago and are working on finalizing the results. But have shown for emissions, well, first that the combustion was very good in this engine without the need for adaptation, and even the nitrogen oxide emissions were lower as compared to the test of the comparison, the reference, which was the ethanol. Some other work that's being carried out at Lund University, direct injection spark ignition in the diesel cycle engine, and they have found so far, looking at very good efficiencies, 54% possible, and they're going to do some further testing with glow-plug concept. And the case study of the Swedish road ferries shows a ferry we're looking at in the project, a Jupiter road ferry. It's 86 meters long, a passenger capacity of almost 400, and carries 60 cars, and it currently runs on diesel fuel. The interesting thing with the smaller vessels, they're already not having a large bunkering infrastructure, but they're having the fuel brought to the ferry in a road tanker truck. So this would be something that would be very easy with methanol as well. And the other project that was mentioned earlier is this Green Pilot project, where the pilot boat has already been converted to methanol operation, and it has only run for about 60 hours. Here you can see the vessel up in Oslo, Norway. It was sailed from Gothenburg to Oslo on methanol fuel with the engine that was a WHI engine from Vitec, conversion process there, and also there'll be another engine tested within the boat. It will be a Scania engine. So looking at different engines, and the boat has been retrofitted with methanol fuel tanks and the safety systems. You can see a lot of the similar partners in this project. The partner, Scandinavis, was the one that did the conversion on the boat, the design and the fuel conversion. So there was a lot of interest in Oslo, the very big North shipping trade fair there, and the boat was there, and also there was a booth there with both projects. A lot of ship owners seem to be interested. It's a very new thing with methanol and shipping, so questions even about what is methanol, and we're explaining the benefits for emissions. And the projects have shown so far very good potential for smaller vessels, and that just a few things that would be good for further uptake, of course, the commercialization of an engine concept, and also that it's very important for the ship operators, for the state agencies to be able to know that there will be methanol, green renewable methanol, available in the future. Thanks very much.
No, that's not the one. Yep, that's one. How do I get it? Yeah, there it is. Okay, hello everybody. Thank you very much for coming, inviting me here. My name is Per Steffensson, and I come from Stena in Sweden, which is a shipping company. We are the largest ferry shipping company in Sweden and Northern Europe, I think. And we also have some other shipping, like a tanker fleet for about 100 ships and some ro-ro ships and drill ships also, actually. But when it comes to the methanol, it is, of course, the Where's there? Where's up there? You can't do it with those? Okay. I continue now. Well, the challenge, of course, was this, as Joanne mentioned before, that we got this new sulfur directive over the Northern Europe, where we had to decrease from 1% sulfur down to 0.1% sulfur. And the decision for that was taken in 2008, and it should then come be implemented the 1st of January 2015. And as soon as this decision came through, we had, of course, to think really about how should we take care of those things. And there are a few different options. And one was, at that time, you should remember that the oil was about double the price that we have now. And so the heavy fuel oil that we were running on, that was about $600 per ton. And the marine gas oil, which would be the low sulfur fuel that was available, that would cost over $1,000 per ton. So that would be a 40% increase in price for the fuel. And then you should know that fuel is really one of the big costs for shipping, especially for ferries. Other option was, of course, then to try to find some alternative fuel. And there everybody said that you could go to LNG, no problem. LNG, it's a cheap fuel and so on. And we started to do the calculations, and we realized that this doesn't make sense. It will cost enormous money to retrofit the ship for LNG. Well, of course, there is one more possibility, and that was to close down within the Northern Europe and start up somewhere else, but we didn't really want to do that. You know, Stena Line is quite, what do you say, our base is in Gothenburg in Sweden, and oh, it's working now? Yeah, thank you. So this is the challenge I was talking about, and you can see that Stena Line's shipping line, they are within these purple fields, most of them. It's only the ones in the Irish Sea that for some reason is not a part of the SECA area, but we have some lines there also. But otherwise, all our lines is inside this SECA area. Now it works. So this is the alternatives that we had, and as I said, we were looking into the different alternative fuels and so on. At that time, electricity hadn't come yet, but that is really coming quickly now as a hybrid thing. But at that time, it was not really feasible yet. So we thought that, well, methanol is a good idea. And why methanol? Well, we have heard it already. It's a clean fuel. It's a large commodity. And the feedstock was the same as the LNG. And it showed that when we did the calculations that it would cost about a third to do the conversion to methanol instead of doing it for LNG. So for us, it was a no-brainer in that sense. And then, of course, we have this also with green methanol, that you can make the methanol from a lot of other sources than the gas. That would give us a path towards a more energy-friendly fuel. Or even more energy-friendly fuel, I should say, of course. But I mean, we could then start also to work with the CO2 issue. It's easy to handle. It's a liquid. You don't have to have it frozen down in minus 163 degrees. You can have it in tank ships or tank trailers, and that makes things much easier, of course, to handle it. And at that time, anyhow, it was economically feasible. Unfortunately, in this sense, the oil prices is now below the methanol prices. So that have, of course, slowed down our retrofitting of the next ships and so on. We have to wait, I think, until we can find economical incitments for that again. The challenges is that methanol is a low flashpoint fuel, and that means that you're not allowed to have it as a ship's fuel. So what you have to do is to prove that, because there is a regulation saying that if you can prove that the alternative you have is as safe as the 60 degrees flashpoint fuels, methanol has 11 degrees flashpoint, then you are allowed to use it. So that means that we had to do a lot of risk analysis and things like that, and we had to take the same precautions, you could say, more or less as with the LNG ships, meaning that we have double piping and things like that in the installation. Oh, I did something wrong here. Never mind. There are some other challenges also, but I mean, this, as you said, toxic. We have heard that before. It is not that enormously toxic, but you always hear it. Everybody's bring it up when you're talking about methanol. So we have to deal with that also, mainly through education of the crew, actually, and so. And then, of course, we had to have some other detectors for fire detection and things like that, and also education of the crew how to put out the fire in methanol and things like that. Anyhow, so we decided to take one of our big ferries, the Stena Germanica, take it to Poland and to retrofit it. And what we did there was actually we found a tank that normally is ballast water, a permanent ballast water tank in the ship. We emptied that and we painted it with zinc coating, and then we had that as a methanol tank. We added a inert gas system so that we could blanket on top of the fuel with nitrogen, and then we have built the world's largest common rail system, I dare to say. It's about 60 meters long from the high pressure pump and into the engine room and the engine. And there on the engine we have built this common rail system. That means that we have double fuel systems now. We kept the old one, and then we have a new additional fuel system. And the only thing then that is connecting those two systems is the spreader. That is a new developed spreader which can work with both oil and with the methanol. And since methanol is an auto fuel, you heard here before, it's high octane and so on, so it doesn't really work in the diesel engine. We had to ignite it somehow, and in this case we ignite, for every stroke we ignite with a little, about 5% diesel oil, and then we inject the methanol. And in that sense, that's good for a lot of different reasons, and that gives a very good efficiency. So it took about 6 weeks, and then we were ready with the ship. And as you can see here, also the market people were there, and they painted this nice sustainable shipping on the ship and so on. And we really feel that we have been making one step towards this sustainable shipping that we all want. How did it go then? Well, now we have been running about 3,000 hours with the first engine that we converted, and we have had some small issues, but not really very big issues. Nothing for what you say, a big technical problem or anything like that. There's been some small leakages. We had some vibrations in those long pipes and so on, but really everything has really been worked fine, and we and also Wärtsilä, who has been involved in this all the time, are almost surprised, I would say. So our next step then, and as I said that already at the beginning, that we need now to, of course, go towards this with a zero emission fuel also. And this picture is from the Swedish ship owners' research agenda. And what it wants to say is that to decrease our emissions with about 30%, which is the first goal we have until, I think, 2030 or something, that is possible with the technology we have. We are saving fuel, and in that way we can do that. But then the next step, we really need the technology breach, and that will be the technology that we have heard about the whole day here, you know, with electrofuel and things like that. So the zero emission fuel, we have already heard about that, I think, today, and that is probably something like this. Of course, when you're doing big steps like this, it is people have noticed it and so on. So we have won, I think, 6 different prizes for this project. So we are very proud about our Stena Germanica. Thank you very much.
This is you, right?
Yes.
There you go. Click right here.
Put it on this side
Right here. That's it.
Yeah, okay.
This is you, right?
and backwards. Yeah.
Backwards here. For Sarah. Backwards. Sarah.
Okay, good. Hello, my name is René Lawson. I come from MAN, and I'm representing two-stroke today. It seems not working.
Just click here. Why? There we go.
Okay. It's a pointer. Yeah. My task for today is to show that we have an engine that can then run on methanol. I will show you here in this presentation in the next 5 minutes. But just for you to give you an idea about who we are. Come from MAN, and we are making engines for ships. And you can see a picture up there of the engines that we're not building them ourselves. It's built by our licensees. So we're running a licensee business. And these engines, they're quite big. They are enormous. And if you look closely, you can see that there's actually people on those engines, but they're quite small. If you take one of them in the front there, then if we say that this engine is going to operate on methanol, it will use around 20 tons of methanol per hour. So it's quite significant amount of fuel that it will consume, these engine. And in service we have in total more than 20,000 engines in service. So there's a quite huge market for methanol there. All of these engines, they can be converted into methanol if owners really want it. Stena is actually the reason why we developed the methanol engine. We had some discussion with Stena back in 2011, 2010, where they looked into the future and said that they would like to focus on this market, methanol in the future for the ferries. So we started to do some investigation ourselves and find out that we can do that. It's not so difficult. And then we started to promote this engine. And the idea was picked up by Methanex in Vancouver, or Waterfront, what they call it at that time. And they decided to order 7 ships, methanol ship. And here you can see a picture from a celebration of the first one, which went into operation in April last year. Today we have 7 of those ships in operation with our engines running on methanol. And altogether we have 7,500 operation hours on methanol. If you look at the engine, the top of the engine, then the methanol system is an add-on system to the engine. So it's an additional fuel that you can use on the engine. All the yellow component is a new component we add on. But basically, we do not change anything on the engine itself. It is a fuel oil engine where we add the injection system for using methanol. And it's quite simple technology that we use for this. And we can achieve efficiency of more than 50%, basically over the whole engine load range from 10% and up to 100%. In optimized point, we can reach 55% efficiency. We're using the diesel combustion principle when we are burning methanol. It's illustrated here where you can see there's two injectors in the combustion chamber, one for pilot fuel, and as Pierre told, we need pilot fuel to ignite the methanol. It's an auto fuel, so we need an ignition point from the pilot fuel. And when there is ignition, we send in methanol at 600 bar pressure, and then we get a complete combustion without any fuel slip. And the fuel slip is quite important when we're talking about methanol, because if you don't burn it all and it goes out into the exhaust gas system, then you turn it into formaldehyde. And on land installation, there's a regulation against that. There's nothing yet on ships. But with this process, we completely eliminate that issue. And here you can see the 2 modes that the engine is being delivered with. It's a gas mode and it's a fuel oil mode. And in the gas mode, we can use up to 95% methanol and 5% pilot fuel to ignite the gas. 5% to ignite the methanol. On a ship, then they will need a few components in order to turn it into a methanol fuel ship. And here's it's illustrated. And of course, there's a tank to store the methanol, and there's a fuel supply system. In our case, we require 10 bars supply pressure of methanol going to the engine. And then we need double wall piping, as also Pierre informed. This is to secure that you don't have any leaks going out and having vapor and any safety issues. The cost for this is quite low compared to what we see for LNG, and this is what it makes it very interesting for ship owner, and especially for retrofit, because retrofit can be done quite cheap compared to LNG. And in service, we have had, if you look at the ships we had in service. We had, of course, had some issues in the beginning, and we still have some we're struggling with, but we have no fundamental issues with the combustion. The whole concept is not changed. It's proved that it works. Safety system has proven that it works as it should do. We have some issues with the pilot fuel and the amount we need to lower that a little. We have the spring in the pilot fuel valve is breaking, and there we have some issues. But fundamental, this whole concept is working, and it's a matter about months or maybe a half a year before we have solved all the issues. So the engine is available as it is, and another issues that we are working on is to make it able to fulfill Tier 3 regulation. And here we have an idea that we can inject some water into the methanol. And because when you inject water into the methanol, you lower the combustion temperature. And reducing the combustion temperature, then you also reduce the NOxes. And we have made tests together with our licensees in Japan, Mitsui, where we compare EGR. It's another method to meet Tier 3 with the water injection methods. First of all, you see there that the efficiency on the methanol compared to fuel oil is better. It's 1% better and 2% better in some areas. So the efficiency point of view, it's also much better than fuel oil. And also efficiency when you are using injected water is better than the EGR system. And can it meet Tier 3? We have done some measurement on with blended water in different load set, and the ring there illustrate the point where the amount of water that we need to inject, and it all fulfills Tier 3 regulation. So we can meet Tier 3 with this. The only thing that we need to complete is now to verify that we do not get increased wearing with all this water injected into the combustion chamber. We need around 40% of water. And this test is running at the moment, and we expect to have a conclusion end of August, and then we'll finalize this design. We see that there is an interest, especially if we can use methanol in combination with this water injection system, because it will actually ease the abatement system for fulfilling Tier 3. In terms of emission, if you compare that to other types of fuel, then we can meet all the regulation there is with fuel oil. What methanol can offer is that it's a more simple solution compared to other solution, and then it's easy to operate when you have it on the ship. What is needed is simply the cost of methanol. It has to come down, and it has to be competitive to at least marine gas oil or the low sulfur fuel coming in 2020. And this is where the big hurdle is. We see also that if you look at the market, if there is an increased demand for methanol, then the price immediately increase on the market. And the ship owner, he cannot plan for having that if suddenly his cost for fuel is going up. Thank you. That was my presentation.
How do I advance the slides?
Here, just click. You can go like this.
Probably use that old-fashioned way. Okay, thank you. Thanks. Okay, good afternoon, everyone. As Ben mentioned in the introduction, my name is Jason Chesko. I work for Methanex. As well, at Methanex, we have our own wholly owned subsidiary shipping company called Waterfront Shipping. This vessel in this slide is actually one of 7 new methanol dual fuel vessels that we introduced into our shipping company last year. So these vessels, when we were growing our business over the last 3 years, we had a need for more vessels. When we looked at the emerging regulations in the marine industry, where we needed to use cleaner burning fuels, and the fact that we're already carrying methanol, and the cost to build this vessel to make it methanol dual fuel was modestly more, so it made it a very easy decision for us to take delivery of 7 new vessels. And these vessels can continue to run on heavy fuel oil, diesel, or methanol. It can actually switch between the fuels at, again, a very modest incremental cost. So a very good business case. I'll talk a little bit more about that in the presentation. I also wanted to focus my presentation more on North America, given where we are here today. So just briefly, a little bit about Methanex for those who don't know us. We are the world's largest methanol producer. So we have methanol production in 6 countries, including a large production base in Louisiana and Alberta in North America. Commercial offices around the world to serve our customers. Terminals scattered around the world as well to service our customers. And as I mentioned a second ago, a large shipping company. Most of our methanol is moved by large chemical tankers. And here's sort of a snapshot of that. So we have the 28 vessels. The 7 new methanol dual fuel vessels we delivered they're all 50,000-ton vessels for a total of 28 vessels in our fleet. So just Per had shown a slide on the European ECAs, known as emission control areas. So we have the same thing here in North America. The International Maritime Organization has put in these new regulations effectively about reducing sulfur. And they even went further in North America, where they're also reducing NOx emissions. So as you can see from the slide, starting in 2015, if you entered within 200 miles of the coast, you had to start using a fuel that was 0.1% sulfur or another abatement solution. Similarly, starting in 2016, if you're building a new vessel, that has to meet Tier 3 NOx. And Renee was talking about how with methanol, you can potentially get to a Tier 3 NOx without having to put in selective catalyst reduction or exhaust gas, pretty complex solutions to do that. I think, stepping back a little bit, so why are these regulations put into place? It's about air quality largely. So when the US EPA looked at this, when they originally were trying to gauge the estimated benefit of this, they had calculated roughly about $100 billion in cumulative health cost savings to switch from heavy fuel oil to a cleaner burning fuel. So that really largely around respiratory disease. It happens from diesel fuels, and hence the move to a 0.1% sulfur. I think there's a real good opportunity here for methanol. As you see in the bottom of the slide, methanol reduces emissions significantly more than diesel. So you're more than meeting the regulations. The diesel that most shipping companies are switching to now is 0.1% sulfur. So a lot cleaner than the 3.5% HFO we talked about, still cleaner than the 1% sulfur. But methanol's got no sulfur. So you're effectively eliminating all of your SOx, all of your particulate matters. And methanol, even without the technology that Renee was talking about, naturally reduces your NOx emissions by 60%. So significant incremental cost savings if you use methanol, say, versus marine gas oil, which is what most of the shipping industry is doing today. So then the next question a ship owner or operator will ask, well, what about the cost of the fuel? Is this competitive? So I would say this chart compares methanol, adjusted for its energy density difference, so it does have less energy than diesel. And just in terms of terminology, MGO, marine gas oil, is effectively just a terminology for low sulfur diesel. And I think to me, some pretty key points come out of this slide. When oil was at higher levels, methanol tended to be less expensive. So 2010 through 2014, methanol was considerably cheaper typically than marine gas oil. As oil prices have come down, that argument you heard from Renee and Per, That the economic advantage isn't there, but it's still competitive. It depends a little bit on where you're operating. I would say in Europe, methanol is a bit challenged to compete with diesel, whereas here in North America, MGO prices are higher, and methanol is actually quite competitive, and in many ports today, still cheaper than diesel. So we have a cleaner burning fuel that's cost competitive. And then we have a growing U.S. Domestic methanol industry. So this is a picture of us moving 2 plants from Chile to Louisiana. A number of other methanol producers have also built plants here in North America. So we're at a point here where we've got enough methanol for the domestic industry, and methanol starting to move to Asia, to different markets. So, much more efficient to keep that methanol here, use it as a clean burning fuel that can help with job creation, domestic resource. You've heard some other presentations on that today, as well as add incremental health cost benefits. The other thing that's, I think, pretty positive about methanol is we already have the infrastructure in place to supply the marine industry. So other alternative fuels are being challenged right now because there isn't the infrastructure, there aren't the ports having it there. With methanol, because we have a mature chemical industry, methanol is already in the ports. It's, this chart here shows rail networks moving methanol around North America. Those little flags, they're hard to make out, but it's effectively showing that there's already methanol all around us in the Great Lakes, in the coastal areas. And it's, compared to diesel, compared to heavy fuel oil or marine gas oil, it's a safe fuel. So in the event that you actually had a spill of methanol in coastal waters, in inland waters, methanol would effectively biodegrade, within a relatively short period of time. As Rene and Per have talked about, we have 8 vessels already running on methanol today. So we've already got 3 international ship classification societies that have established rules to safely use methanol. DNV, Class NK, and Lloyd's Register, all have rules to safely use methanol. I won't spend too much more on this. We've already talked about the technology, but the key point is both MAN and Wärtsilä, large international engine companies, are producing methanol-compatible engines, and they're pretty straightforward. You're just effectively adding a fuel system to an existing diesel engine and adding another liquid fuel into the engine. So pretty low cost and pretty innovative. And here, again, here's our 7 new methanol dual-fuel vessels. These were all delivered throughout 2016. The vessels have been operating several thousand hours since they've been introduced and operating reliably and safely across the globe. And I think Joanna covered this pretty well. There's a number of other R&D projects going on beyond, not just the small engine market, but also the large engine market, where typically governments are partnering with industry and other stakeholders to study methanol further. So you have the Methaship project in Germany that's looking at cruise ship design, the lean ships and the green pilot project that were mentioned already. And finally, I'll mention in China, Methanex has been working with the class society there about supporting the development of rules for methanol. And we're also working on a pilot for a smaller vessel to use methanol in the inland waterways in China, where pollution tends to be a significant issue. So thank you very much.
Right, thanks, Jason. So we've got about 10 minutes actually for some questions. So if we have any questions from the audience, just in the back there.
If you guys could put your earpieces on, if you have them. I know you probably have put them away, but if you'd like to hear this question.
你好。
Hi, I'd like to ask a question for the representative from MAN. I'd like to know what is the replace rate for diesel? So for the methanol, because we use diesel injection, then we burn the diesel and methanol together. So I believe in MAN, it's also ignition by diesel, then then burn the ethanol, and I'd like to know the rate. And next question is to the waterfront shipping, and because I like to know the near shore fishing ship, because my next year work is in this part too, because we don't have methanol fuel vessels. So but for our fishermen, they don't use this kind of. We don't have a methanol refill ship. So, but we do have a diesel refill ship. I'd like to know if you have this kind of methanol refilling ship to provide the methanol supply to the other methanol fuel vessels. Thank you.
The last question there, that was for you, Jason, and it was around just some further background on the project in China with the fishing vessels. There was a question around, there's infrastructure in place for putting diesel onto these fishing boats. What's our plan in Jiangsu province, and what does that project look like? How is that developing?
So we're working on it this year. We're partnering with the Ministry of Agriculture on that project. Have targeted to do this on a fishing vessel, and I would say similarly, there's already quite a bit of methanol, in the inland riverways. So there's infrastructure there that can be used for methanol. So by the end of this year, we'll have that firmed up, but that's our target, have that pilot firmed up with specific deliverables by the end of this year.
Couple of questions. Excuse me.
Yes, Mark Goodman from Eastern Research Group. I think it was Mr. Larson, is that you? Yeah. I mean, talking about the engine where you mix the 40% water with the methanol. You do that like at the injector port or where?
No, it's done in the supply line towards the engine. So right before the methanol is being delivered at 10 bar pressure in a pipeline, and before it reaches the engine, then we add water to the methanol. So it's a separate water tank, and when you operate within Tier 3 region, then we inject this water into the flow of water in the pipe system. So it's quite simple, and we hope we can adjust the water depending on engine load. Because when we operate at high load, we need maybe only 5% water. When we operate at low load, we need around 40% water. Less water, more efficient operation. Water will have a tendency to lower the efficiency.
We had a couple questions over here.
So being able to do this in the marine industry is very exciting. But is there anything that would stop the same technology from being applied to people who are using diesel engines for producing electricity, such as many places on Earth?
I guess that's to me also. Yeah. Yes, it can easily be done. We have also engines for power plant, so we can also offer that. It is basically the same engine. You just connect it to a generator producing electricity, so it can also be done. I would say where we see the biggest potential for methanol is on board ship in the future. People they think when they look at the future, then the two-stroke engine will disappear because there's so many new technologies coming. There's batteries, but on batteries on bigger ships, taking long distance, it's impossible. We will not see that in 50 years. So here, methanol is really the best way to store energy and use that on board ship. And this is where we see the future for methanol. But we need simply the production of methanol to increase, removing all these high peaks of high prices on methanol before owners really trust that it is a solution which is available.
Maybe I'll just add on that last question. As Rene said, MAN has engines that run power plants, so does Wärtsilä. So that it's effectively that same technology can be used in power plants. So Methanex is actually involved in business development initiatives to use methanol in power plants. And there's very similar themes happening in that market. So for example, in the Caribbean islands, you've got some islands that have to switch away from heavy fuel oil due to environmental regulations. So they're looking at cleaner burning fuels, like diesel, like methanol, or I would say like methanol, LNG. I think methanol competes very well on those kind of small, kind of remote areas that are already using liquid fuel for a reason, because it doesn't make sense to build all that infrastructure for an LNG, for example.
Jason, perhaps you could make a quick comment as well on the industrial boilers, effectively how methanol is being used there in China and the sort of growth that you're seeing.
Sure. Yeah. So China, we know, we saw earlier today, I think uses about half of the world's methanol. They're using methanol. They've used methanol for a long period of time as a fuel because it's economical, but more and more we're seeing them do it for clean air benefits. So industrial boilers, I think China's a little bit unique, but I think they have about 600,000 industrial boilers. Most of those run on coal. Coal is very, when you burn it near concentrated centers, very polluting. So regulations are in place in China to switch away. So methanol is one of the fuels that's being used. I think there's already about 1.5 million tons going into these boilers. Methanex is involved in a pilot involved in a pilot and working with a lot of the government agencies there to set standards, because we want to make sure the standards in place throughout the industry to have this done responsibly.
Yes, thank you.
Last question.
Yes, congratulations, by the way, for both the MAN, Stena, Wärtsilä's tremendous leadership, and it's really exciting to see that you're near the Tier 3 compliance point. I was wondering, Rene, if you might discuss a little bit about the particulate emission impacts of using water injection. I would expect there to be a slightly higher PM rate with water injection, but maybe you're not running into that. I'm not sure.
I'm not sure I'm really able to answer that, because we have not measured that part yet. That will come later. First of all, we need to see if that it is a feasible solution, that it works, and then we go to the smaller details thereafter. What we need to conclude now, if we inject, let's say, 40% water into the combustion chamber, we need to look at the wear on the combustion, corrosion issues, such things, and we need to overcome that before we can move forward to the next. But particulate matters using methanol is almost none. Yeah.
Yes, I would just like to connect maybe to the last question, or the question before. One thing when it comes to methanol for the maritime sector is that we are the fuel. The cost is the cost. We don't have any incentives, in tax. So there's no way that you could elaborate with the taxes and things like that. So that means that the methanol has to be compatible with the oil price to really come through. And therefore, I think, and we have discussed that a lot with many people here, but I would like to say it anyhow, that maybe in the future, I think that it would be a very good thing to have a kind of a fuel grade of the methanol. It is not necessary to have a chemical clean methanol when it comes to run it in an engine. You hear here, he wants to dilute it with 40% water anyhow. So if there is a little water from the beginning, it really doesn't matter. And if there is some ethanol in it, it really doesn't matter either, because that burns fine too. So I think for the future, there will be something to think about, and that would be a fuel grade for the methanol.
Thanks, Per. So, yeah, you said the cost is the cost, and that's true. What we are seeing is really the regulations are altering what that cost that you compare against is. So, as these regulations get stricter and stricter, you need to use cleaner and cleaner fuels. And so as those cleaner and cleaner fuels are required, then methanol becomes more and more competitive versus those fuels. So, I think if that's one of the common themes that I heard today is that the government policies, whether it's individual nations or the IMO, is really paving the way to methanol becoming increasingly competitive over time. We're already at the point where it is, but we expect that to continue as the fuels get cleaner. So, we've heard today from a whole variety of different applications, whether that's the large two-stroke engines, the developments there, the four-stroke engines with the Standard Germanica, or the high-speed engines that Joanne was talking about. And there's certainly a big opportunity to use methanol in inland waterways where they're using some of the highest quality diesel, which is some of the most expensive diesel, to replace that. And so we're going to see more and more of this happen over time. The challenge, as you all know, is that since 2014, the oil prices have continued to decline and have stayed relatively low. So that's one of the things today, I think, that is a challenge where you need to look for niche opportunities. So it's not competitive in every region. Now we expect oil to change again in the future, but a lot of this is about picking out the opportunities that make most sense today and continuing to develop that technology, because sure enough, whether it's next month or next year or in 3 or 4 years' time, we'll see another cycle in oil prices as well. So I'd like to thank all of our panelists today for the presentation. Certainly very interesting. Got lots of interest from the audience as well. And I'd like to hand it back to Greg and Gal, Annie, to close out for the day. Thanks.
Well, first of all, thank you all for staying for a whole day of, I think, what were very stimulating presentations. There are a few messages that I would like you to take away from this day and just keep hammering at these messages to our policymakers, because this is what it's going to take to make it happen. And what I mean by make it happen is open the transportation fuel market to methanol in the United States, because in China it's happening already. And in Israel, we heard there's movement in the right direction also. So, first thing, methanol is probably the best way to increase demand for natural gas in the United States and elsewhere. And second, because of the tremendous arbitrage opportunity between natural gas and oil, increasing demand for natural gas via methanol delivers benefits not just to natural gas producers, but it will deliver huge benefits to transportation fuel consumers, because they're going to see reduced pricing per mile for fuel. They'll get some of the benefit, and the producers will get some of the benefit. It will be good for everybody, and it will smooth out prices of transportation fuel. And third, in China, despite the fact that methanol is made from coal, methanol from coal cleans up the air in China. I think that's a tremendous thing for people to get across. When they think of methanol, methanol is a really clean fuel. There are no particulates. So that's a super important message to drive home. And of course, the last is Boyden Gray's example that if anybody ever tells you methanol is toxic, ask them to drink some gasoline and see if they're willing to do that. So thank you again to all of our speakers from around the world, China, Israel. We have people here from Australia, right? We have people here from Europe, from every part of the globe, and of course, many speakers from across the United States. And thank you to our audience, and thank you especially to our partners at the Methanol Institute, with whom we've been working for many, many years. I truly believe that in 20 years, we're going to look back and say, how did it take so long for the United States to open its transportation fuel market to methanol? It's a complete no-brainer. And I think that the Chinese Sputnik, the Geely methanol car, the other methanol cars in China are going to really be a spur to drive the competitive spirit here and get things going in the United States as well. So, Greg, over to you.
Well, thanks, Annie, and I want to thank all of you for attending today. I hope this third Washington Methanol Policy Forum has been informative for you. I encourage all of you to feel free to reach out to myself or Annie if you have any follow-up questions or requests for information. As was noted, we're going to be sending all of you an email with links to our websites once we get the presentations from today posted. We're also videotaping this session, so we'll have video available as well on our websites and our YouTube page as well. I would like to, again, thank our sponsors for today's event: CEL, Methanex, Mitsui, OCI, SABIC, and Southern Chemical. It's truly without their generosity, this event would not have been possible. I'd also like to thank again all of our presenters. Without their willingness to share their knowledge and expertise, this event likewise would not have been possible. I'd now like to invite you to join us next door for a reception. The reception will be held at the JW Marriott's Penn Avenue Terrace, where we'll have the privilege of hearing from Representative Elliot Engel of New York, the sponsor of the Open Fuel Standard Act. We'll have staff available as you leave to direct you how to get to the JW Marriott. It's pretty simple. You take the elevator down to the first floor, go out the door, turn left again in the JW, and when you get into the JW Marriott, you'll see signs for the Methanol Forum reception. And again, it's going to be at the Penn Avenue Terrace. So again, thank you all for your attendance today. Remember that methanol is the clear alternative. And as we're getting ready to head out, we're going to try to have one more little video we can put up there. Walter Bridenstine from Gas Techno has a video about their small-scale methanol production. So we'll try to get that running as we're clearing the room. So thank you all.